This continues our practice test A, our third objective. We're on the letter B, the second series of questions. We're being asked to use an activity series to predict whether a reaction will occur if a metal is added to an aqueous solution of either a metal salt or an acid. From there, when I hear activity series, we'll need a tool page, and it's just a series of elements from the strongest of strong at the top down to the weakest of weak at the bottom. The activity series shows the ease of oxidation. The activity series are always used for single replacement reactions, so every one of the patterns here for this first series of questions will be a series of single replacements. A plus compound BC, A kicks out B if it's strong enough, giving us a new element B and a new compound AC. It's this negative ion that typically ends up to be the spectator and will get eliminated when we move from molecular to net ionic. So let's begin checking our answers. Iron metal, and I know it says include all adjectives, but I really won't grade those. So you may choose to write those out, but not necessary. Iron metal is reacting with a solution of copper 2 nitrate. Copper with a +2, nitrate with a -1, so we get CuNO3 taken twice. Checking the activity series, we have to see if iron is strong enough to displace copper. Is iron stronger or higher up on the activity series? Here's the iron, here's the copper. Iron is indeed strong enough, more active enough, easier to oxidize compared to copper, so this reaction will indeed go. Iron kicks out copper, so it now is by itself, and it hooks to the nitrate, and I'm just going to keep it at the same charge, a +2, as we did for the copper to make the ease of balancing. Iron in nature can be a 2 or a 3, so I'll select the iron 2 nitrate. Just to stress, they're not necessary, but a solid iron goes to an aqueous solution, producing a new metal that's solid, giving an aqueous solution of iron 3 nitrate. Now, thinking about Leo and Gur in our oil rig, when we think about oxidation and reduction, iron started as a 0, went to a +2. Iron is being oxidized by a change of 2. Copper started as a +2, went to a 0. It is being reduced by a factor of 2. To eliminate the spectator ion and simply show the net ionic, I show Fe, the atom of iron, plus the aqueous ion of copper at a +2 charge, forming copper metal as a solid, and the aqueous ion of iron, Fe, at a +2 charge. Notice that the charge and the number of atoms is indeed balanced on both sides of the equation. Zinc metal added to a solution of hydrochloric acid. Zinc metal, Zn, as a solid, to a solution of hydrochloric acid. Indeed, one of our 7 strong we're working to memorize, HCl. If zinc is strong enough to displace hydrogen, a reaction will occur. Zinc indeed is above hydrogen on our activity series and can displace it from a hydrogen that's in an acid. Zinc kicks out hydrogen, so it forms molecular hydrogen, H2 is a gas, forming an aqueous solution of zinc chloride. And remember, based on charge, we get a +2 with a -1, ZnCl2. Solid zinc with aqueous hydrochloric acid, giving us hydrogen gas and aqueous zinc chloride. We'll balance that equation with a 2 in front of the HCl. To stress the redox, we see that zinc, a natural element in its state, would be assigned 0, went to a +2. Zinc is being oxidized. Hydrogen started as a +1, went to a 0. Hydrogen is being reduced. Let's show that in the net ionic equation. We're showing a change of charge in the single replacement, eliminating chloride, the spectator ion. Solid zinc reacted with 2 aqueous ions of hydrogen to form molecular hydrogen gas and an aqueous ion of zinc at a +2 charge. 2 units of a +1 balances 1 unit of a +2, so we have indeed balance by the number of atoms and by the charge. Let's try number 3. Aluminum metal, so solid aluminum, added to a solution of nickel 2 sulfate, so NiSO4, and that is aqueous. Is aluminum strong enough, active enough to displace nickel? Here's aluminum, here's nickel. Indeed, aluminum is more likely to be oxidized. It's higher up on our activity series, so this reaction will go. Aluminum displaces nickel. Nickel now is the solid metal. Aluminum hooks to the sulfate, Al2SO4 taken 3 times. Let's balance. 2 aluminum, so I'll double here. 3 sulfates, 3 nickels. A 2-3-3-1 balances that molecular equation. Thinking about the redox, here's aluminum as an atom, an element the way we find it in nature, assigned a 0. It is being oxidized to a +3. Nickel started as a +2 is now reduced to a 0. Eliminating the polyatomic ion sulfate, and let's show the redox net ionic equation. 2 aluminums, no charge, these are metal atoms, with 3 aqueous ions of nickel at a +2 charge, forming 3 nickel atoms in a solid form plus 2 aluminums each at a +3. Those are aqueous ions. Solid aluminum, aqueous ion. Solid nickel, aqueous ion. Ions are charged in water. Not only are we balanced by the number of atoms, we've balanced by the charge as well. 3 units of a +2 electrically balance 2 units of a +3. Let's check our 4th problem. Potassium metal is added to water. Remember, I like to write water as HOH in a single or a double displacement. It helps me to predict my products. Writing water as HOH helps me see that a base is the product. Potassium, checking the activity series, potassium is indeed high enough on the activity series to react with hydrogen even though it's in a water. Remember from lithium down through sodium, and we drew a line. Lithium to sodium reacts with acids and water. From magnesium to hydrogen, all of these metals here are acids only. And we talked about that in our first year chemistry. It's a little asterisk that's down here, tiny. So this reaction will indeed go. When potassium displaces hydrogen, molecular hydrogen gas forms. And potassium grabs the last name of water, which is hydroxide, KOH. We'll balance 2 H's, 2 H's, 2 OH's, and 2 K's with a 2-2-1-2 stoichiometric ratio. Now with this net ionic equation, potassium started at a 0, went to a +1. It is being oxidized. Hydrogen started as a +1, went down to 0. It is being reduced. Interesting, however, is that water is a non-electrolyte. It's a molecule. We do not break water apart. The only strong electrolyte is the base at the very end. So when we turn this molecular into a net ionic equation, we get 2 potassium atoms that are solid plus 2 molecular waters. I'll just join it to make it look like a water molecule. 2 molecular waters. Those are liquid. forming hydrogen gas, a molecular molecule. And now this is strong, so we break it apart. 2 potassiums and 2 hydroxide polyatomic ions. There are no spectators, nothing to eliminate, but I do have one strong electrolyte that I need to dissociate at the end. Pause the video here. When ready, make the next click onto the next section of your practice test.